How's everyone doing? Thank you for coming. My name is Felix. I'm a software engineer at Very Good Ventures, and today we're going to talk a little bit about the Bloc Library. Before we jump into it, though, I'm happy to announce that I just recently joined Very Good Ventures with my coworker Jorge. So we have a Chicago office. If any of you are ever in Chicago, definitely come talk to us. Jorge runs the Chicago Flutter meetup, actually. So if you're ever in the area, we would love to talk to you and grab coffee. Before that, I actually worked at BMW as a software engineer. So during that time, we went from having two separate code bases for iOS and Android to creating a single Flutter application. And that's kind of when the Bloc Library was actually created and why we even started working on it in the first place. So that was about 2 years ago now. And in the very beginning, we started off trying a bunch of different things. We tried Redux, we tried RxDart, and following the block pattern that Google announced in their ads team. And everything seemed like it was going well, but after a while, we realized that Rx, while it was very powerful, at the scale that we wanted to use it, it was actually very tricky because it can easily be misused and cause lots of problems. And so we wanted to try to kind of take all the good from there, but also prevent any damage from being done by the misuse of the tool. So we wanted to keep it as simple as possible, but still have a powerful solution. So we had a couple of goals that we outlined. We still wanted to kind of separate our view from our models. We wanted to have this nice separation so that we can reuse our code and also have a really modular code base. Obviously, we want to have a code base that's easy to test, and we didn't want to ever make the sacrifice between delivering something on time or with quality. We always wanted to be able to do both. And we also wanted it to be predictable and maintainable. And by that I mean predictable. It would be really nice if we could always have kind of like the same pattern of doing everything. It's not like, oh, person A has their preference, person B has their preference, and it's really hard to jump between. We wanted to have a consistent code base so that developers can quickly go back and forth from one feature to the other and be productive and offer value immediately. And then also maintainable. We didn't really want to have a lot of like manual processes that people have to do, and we wanted everything from like a small team of 3 or 4 people to a team of hundreds of developers to work the same exact way and have something that was just scalable in that regard. So with that, we started working on this Bloc library. So it consists of a couple different packages. We'll go through them one by one. But at the core, it's nothing really new. There's no rocket science or anything. We pretty much took a concept that lots of different frameworks and programming paradigms follow, and it's pretty much there's a single input and a single output for our block. So block, again, we use to encapsulate the business logic, so business logic component. But instead of having many different streams and many different syncs, we wanted to just be very strict and say every block only has one input and one output. So events come in from one sync and states come out from the other sync, and the block has just one job: convert those events into states. So you might be wondering, like, okay, what does this actually look like in an application? So how many of you have run Flutter create and saw the counter application? Can I get a show of hands? Cool, so most of you. So you might be wondering, like, okay, let's take the simple example and see how would block actually slot into that. And so in the case of the counter application, we could just have our floating action button in the bottom corner, and anytime a user taps on that, we can add an increment event to our block. Our block could then do some complex computation, so it could be like, okay, I started at 0, I got an increment event, 0 plus 1, that's 1, and then output it, and the UI could be like, okay, cool, I got a 1, let me redraw myself and update for the user. So pretty simple, and we have this nice separation of the logic from the UI. So in practice, if we wanted to actually build this, we can just start by, let's assume our counter block is a package that we're going to ship independently. And we'll add a dependency to the Bloc library. Notice there's no dependency on Flutter. This is just Dart code so far. And we'd need some imports. So we need to rely on the Dart async library because we still work with streams. And we also imported the package. So we're going to be using some things from the Bloc package. And the very first thing before you even write any code, in my opinion, the hardest part is actually coming up with what are my events and what are my states. So you have to really think about how am I going to name things, how am I going to structure my block so that it actually makes sense and is easy to read, and having consistency basically across those is, I think, the hardest part. But let's say in this case, we just have an increment and a decrement event. So we can represent that as just a simple enum called counter event. But there's no really opinion on how to do this. Like, you can use classes, you can use primitive types, you can use whatever you want to represent your events and states. So we start with this enum for our event, and for our state, we can just use a simple integer, since we're just going to represent the count or the value of the counter. And the next thing we need to do is actually create our class. So counter block extends the block class, which comes from the block package. And again, we have to specify the types of the input and of the output. So this is going to be a block that takes input of counter event and outputs integers. And at this point, if you're following along, you'll see some squiggly underlines that say, okay, we're missing some overrides. So the first override is the initial state of the block. Every block has to have one, and it's basically the state before any events are added to the block. So if I never interact with the block, but I want to consume it somehow, what is going to be the value of the state? And then the second one is this map event to state function. So it's an async generator, that's the async star. And all that means is it's going to return a stream of integers. So we're going to convert counter events as our input into a stream of integers or states as our output. We can do that easily in the counter example by just switching on the event. And for the increment case, we're just going to yield the current state of the block, which we can access via the state property, +1. And then for decrement, we can do the same thing, -1, right? So all in all, we have this little chunk of code, and that encapsulates all of the business logic that you need for this counter application. So we've written it in Dart. We haven't touched Flutter yet. Let's take a look at how would you actually use this. And again, we're not even going to get into Flutter. This is all just Dart. So since we wrote this as a package, we can import our package in our main. And then we can just create an instance of this counter block. We can call listen on it. And thanks to Brian recently, we actually changed block so that it actually implements and extends stream and sync. So all the similar APIs that you're familiar with, they apply to block as well. So we can just listen on the block. And anytime a state is emitted from the block, we can just call print with that state. And once we're listening, we can start adding events to it. So we can add an increment and add a decrement. And now we can flip over to our terminal, run our Dart code that we just wrote, and we should see a 0 in our console, which corresponds to the initial state of the block, followed by a 1 for the increment, followed by a 0 for the decrement. Cool. So we have everything working. We haven't written any Flutter code. It's just pure Dart. And we have this nice separation of concerns. So you can really reuse this block in any application you want. It has no idea what the UI or what CLI or web application is going to be consuming it. It's purely just Dart code that you can drag and drop anywhere. So you can take like an Angular Dart application on your right or left. Yeah, left, I think, and a Flutter application on the right, and they can reuse the exact same application or exact same block and have totally different UIs, totally different use cases. But if the business logic or use case is the same, you can reuse the block. Just drop that block in, wire it up to the UI however you'd like, and you're good to go. So you don't need to be duplicating that business logic everywhere. A lot of times people are like, okay, I hate when you see or you show me counter examples because it doesn't really show me how everything works in the real world. So what if I want to make things like network calls or read databases or things that are asynchronous? How would that actually look? So if we go back to our counter example, let's assume for some crazy reason we want to actually make a request that's asynchronous to get our value or our counter. We don't want to actually compute all that locally within the block. We can represent this pretty easily. We just need to change how we actually represent the state. So instead of an integer, we can change our representation to use a class. So we can have a counter state. And we can subclass the counter state and have a counter load in progress, which would be the state of the block while it's fetching asynchronously whatever data it needs. We can have a counter load success, which contains the value of the counter once we've fetched it successfully. And we can also have a load failure, because you can always have a failure, right? If you make network requests, we should handle those failure cases. And then the next thing we need to do is just change the type of our block from outputting integers to outputting counter states. And let's just assume that in this case we have a counter service or repository or whatever you want to call it that the block is going to be interfacing with. That's going to encapsulate all of the asynchronous data transformation and sending things back and forth. So that gets injected into the block. We can update our initial state to just start off at in progress, load in progress. If you want to just start with like a loading indicator, for example, you can even create a separate state, like an initial state if you want to show some empty content right away. And then we can swap out our +1, -1 for the states for these private helper functions, basically. So we use the yield star or yield each to basically break out all of these other asynchronous generators that we're going to write and not clutter our map event to state function so you don't have all of your logic in one single place. So if we take a look at one of these, it should look very familiar. We're just breaking everything up into handling one event at a time. So this one is only going to handle when an increment happens. We're going to immediately push a load in progress as the next state of the block so that no matter what was happening before, we're going to set the state to we're loading something. Then we can wrap our logic in a try-catch so we can await the increment from the counter service in this case. And if that succeeds, then we can output a load success with the value that we got. And if it fails, we can output a counter load failure. So the decrement looks exactly the same. The only difference is we'll call decrement, right? And just suppose that this is actually making an HTTP request or reading a database. Doesn't matter. You can even mock it and just have like future delayed. So the block shouldn't really care. So at that point, we've covered like how you actually build the block, how it helps us separate our UI from our business logic. So let's jump into how you'd actually test it, because that was one of our initial goals, was something should be, or whatever we come up with should be very easy to test so developers don't struggle writing tests and they don't make excuses for testing the code that they write. So we came up with some helpers in this package called block test. And we'll take a look at how we would adapt our code to actually include tests for the things that we just wrote. So we'll start off by just adding some dev dependencies. You need one on the Dart test package, which gives you all the standard like test, group, expectations and stuff like that. And then another one on block test itself. And now we can just get started writing tests. So the first thing that we'll do is define a main. Like every test file has a main. We'll create a group, and the groups we use to basically group logical functionality, so you can execute tests for an individual group if you want, and it also makes a test read really nicely, which I'll get to in a second. And the meat of this is the block test code, obviously. So block test comes from the block test package, and it has a couple things that you need to know. So the first one is, just like every regular test, there's a description for the test. So in this case, once we run our test, it's going to read counter block, emits 0 when no events are added. So it's going to read like a nice sentence. You can understand as someone who's running these tests, what are they actually supposed to be doing. Next we have this build that you have to basically return the block that's going to be tested. So we'll return a new instance of our counter block. And then we have this expectation. So expect is basically going to take a list of the states that you want the block to emit, and in the exact order that you expect them to be emitted. So for example, if we put expect 0, 1, and the block only emits 0 in this case, our test would fail instantly, and it would say, oh, you expected 0, 1, but you actually got 0, failure, because it doesn't, there's a diff basically, or a discrepancy in the actual versus expected. So really handy. You don't have to wait for timeouts and things like that. The test should fail right away, and you get instant feedback as a developer. So if we flip over to our console again and do a pub run test, we'll see like, woo, our test passes, right? But it's a very simple test. It's just testing the initial state pretty much, so nothing that special. But we can go back and add the missing tests in. So let's say we want to test the case where we add the increment event and we get 0, 1. Just like before, we'll have a description, counter block emits 0, 1 when the increment is added. Same thing in our build, we return a new instance of our counter block, and then this time there's this act part of the test. So act is where you can optionally interact with the block that you returned in your build and do things to it, so add events to it, right? So we'll add the counter event increment to our counter block, and now we can expect that 0 and 1 is actually emitted. Similarly for decrement, the only difference is we're going to add a decrement and expect 0 and -1, right? So just a few lines of code, and we've fully unit tested all of the cases that our block should be able to handle, and we're good to go. But you might be wondering, like, okay, we just talked about async code. How would we actually unit test the async code? Because the counter block is really simple. One package that is really handy that we found works really nicely with all of this is Mockito. So how many of you have used Mockito before in your testing? Almost everyone, a lot of people. That's awesome. So as most of you know, then Mockito is really useful for mocking services that your test isn't testing. So in this case, we'll create a mock counter service because we want to have full control over how our counter service behaves in our tests. And we'll write another test. So this one is going to test that our counter block, our async counter block, emits first a load in progress, because that was our initial state, and then a load success as long as we add the increment event. And the only difference here really is in our build. Instead of just returning a counter block, you recall the async counter block had a dependency and we had to inject a counter service. So here we'll just create an instance of that mock counter service first, and then using Mockito, we can say when we call increment on the counter service, we want to return a future that has a value of 1 in this case. And so at the very end, we still have to return our instance of the counter block, but we've injected that mocked counter service inside. And so once we act on it, it'll actually behave the way we expect. So internally, the block will call increment on the counter service, and then we should be able to expect that our load in progress and load success were actually emitted successfully. So all in all, you can see the testing structure doesn't really change that much. You just need to do some mocking of your dependencies dependencies before you actually do your act and expect. So hopefully this will no longer be you anymore. You should never feel like you can't write tests or it's too hard or too complicated. Our goal was just to make developers feel as comfortable as possible writing tests so that you would write your code and then immediately write the tests afterwards, or vice versa, depending on how you feel more comfortable. But yeah, our goal was to just have it be as easy as possible. So we've addressed the easy to test portion. But we kind of cheated because we talked about decoupling UI from business logic, but never really talked about the UI. And this is a Flutter conference, so we have to talk about how everything integrates with Flutter. So there is this Flutter Block package. How many of you have used Flutter Block or heard of it? A lot of people? Okay, cool. That's a lot of people. That's awesome. So Flutter Block, for those of you who don't know, is just a bunch of helpers that help you integrate your blocks into your Flutter UI. So it provides handy widgets that help listen to changes in blocks and access blocks. So if we create a new Flutter application called Counter App, let's say, you'll see that this one actually does have a dependency on Flutter and has a dependency on Flutter Block, and we're pulling in our counter block as well that we just implemented. And we'll start off with just our main, which is pretty much the same as every main. We're going to use material for this case, but everything's interchangeable with Cupertino. And we have the Flutter Block and counter block imports that we're going to use in a second. But we're just going to call run app with our counter application and jump right in. So right off the bat for the counter app, you'll notice it's just a stateless widget. So all we have to do is implement our build or override our build. And in this case, we're just going to build a material application, and we're going to return a block provider which wraps a counter page. So I'm going to pause right there, and some of you might be thinking, okay, block, provider. How many of you saw Remy's talk on provider yesterday? A lot, okay, cool. So you might be wondering, like, okay, are they related? Like, I see the word provider everywhere. And if we take a look at the actual pub.dev entry for Flutter Block, and you look in the bottom right-hand corner in dependencies, you'll see that Flutter Block depends on Block, Flutter, as well as the provider package. So hopefully I don't see people anymore asking questions like, should I use Block or provider? You can use both together, actually, and provider is really useful for making your block available in the widget tree. You don't have to choose between them. They actually are really nice when put together. So now we can go back to block provider. If you're familiar with provider, the API is very similar, and the goal was pretty much to unify on a single dependency injection system. So that's why it made sense to use provider for Flutter Block, so that every developer who's familiar with provider is also familiar with Flutter Block and block provider. So we have the create API, which basically gives you access to a build context, and from there you create whatever you want to provide. So in this case, we're creating an instance of whatever, my block. And we have our child, in this case, the child. And in the child, we can access block provider .of my block to get the instance of the block that we just provided, just like everything else in provider. So that should be no different. A good question to ask would be, what about disposing? Like, I'm used to maybe writing my own blocks from scratch, and I need to create stateful widgets where they have state classes associated with them, and I need to both create my block in init state and then dispose of it in the dispose override. So where does all this code actually go? And yeah, as I mentioned, like, this is a lot of code that you'd have to write over and over and over again. And this is one of the problems we were trying to solve, is how can we reduce all this, because it's really the same every single time. It's very kind of tedious and easy to forget to dispose, because nothing's really preventing you from doing that. You just might run into unexpected behavior later on. But it's something that's really easy to forget if you're trying to ship an app quickly. So block provider actually handles this internally for you. And this is a snippet taken straight from the Flutter Block implementation. So you can see that block provider extends provider, and in the dispose, we call close on any blocks that you provide. So you don't have to worry about forgetting to close or forgetting to cancel subscriptions. Everything is handled internally for you. Another good question is, okay, can I use multi-provider just like with provider and provide multiple blocks? And the answer is yes. There's a multi-block provider, so you can provide one or more blocks, and it's exactly the same as you would expect with provider. So you don't have to have a really nested, lots of nesting in your code and making it harder to read. You can have everything be linear and in a single list, and it's basically exactly the same. It's strictly equivalent to nesting it, but just a little easier to read. So now that we've taken that tangent on block provider, we can go back to see counter page itself. So we provide the counter block to counter page. And in counter page, again, another stateless widget. Again, we override the build, and we put some familiar widgets that I'm sure you all have used. So we have a scaffold, app bar, body, and we center the content of our body, and now we have this widget called Block Builder. So Block Builder is another widget that comes from the Flutter Block package, and it pretty much is like a stream builder for blocks. So it will help you rebuild widgets or parts of your UI in response to changes in the state of the block. Anytime a block emits a new state, like our counter block, if it emits 0 followed by 1, and you use a block builder, the block builder will be called again with the new state, and you'll have to return a new widget. And so breaking it down, a block builder takes the type of block that it's going to be listening for and the type of state. And then you have this builder function, just like in Stream Builder, but you don't have to deal with initial data and async snapshots. It's all handled for you. You just have to deal with the state that comes back from the block. And a good question that might be confusing initially is like, okay, I know my block builder reacts to changes in the block, but I'm never actually giving it a block. I'm just somehow magically expecting it to get a block. Don't I have to actually say block and then look up my block or provide my block instance to block builder? And the answer is, you can, but you don't have to. So if you omit that, again, another snippet taken from the Flutter Block code. If you don't provide a block to your block builder, and this applies to other widgets as well, internally it will do a lookup using block provider. So as long as you specify the type of block that you want your builder to respond to, it will handle the lookup for you, so you don't have to be putting blockprovider.of in your code everywhere. Obviously, you can choose to do that if you want to not use provider and maintain injecting your blocks however you'd like, but it's a nice way to kind of skip writing a line of code if you don't need to. So now going back, we understand how block builder works. So all we're doing inside our builder is just returning a text widget now. So anytime the counter block emits a new state, we're just going to render another text widget, and the content of the text widget is just going to be some text. You have pushed the button state times, where state is just the state of the block that we got at that point in time. And the async version that some of you might be wondering about is going to be very similar, except for we actually need to handle explicitly all the different states. So if my state of my block is counter load in progress, I might want to return some sort of loading indicator. If my state is a success, I might want to return the text widget. And if my state is an error, I might want to return some error. So it forces you to be very explicit about all the possible states that your block can be in and how you handle those in the UI, which is nice because sometimes you forget a lot of edge cases or failing to account for the loading state or the error state. And yeah, this makes it really easy, especially if you're looking through the code and you want to like quickly find a widget. Block Builder should ideally just have, if this is the state, this is the widget. If this is the state, this is the widget. And then you can just go and look at the particular widget that you care about. You don't have to be like trying to figure out like, where do I go to find this widget or what happens in this state. It should be obvious from the very beginning. Now that we have all that, you might be wondering like, okay, how do we actually add events to our block? And we can use block provider. Again, you don't have to, but it's a pretty good way to handle things in Flutter using inherited widget under the hood. So we can just use block provider to look up an instance of our counter block using the build context, save that as a variable in our build, and then create some floating action buttons. So the top one will be our add floating action button, where we can, in the onPress callback, just add the increment event to the block. And then in the second floating action button, which is our remove, we'll do the same thing. We'll just add the decrement event. So our logic, or our UI has no logic. It's very dumb. It's just handling user input and then delegating all those events to the block and then reacting to states from the block. And so you can easily swap out blocks or change the block's business logic, and the UI should not care. It should still behave the exact same way. And at a high level, our application looks like a boring old counter application, but you can look at this diagram that we have and kind of trace through everything and make sure that conceptually like everything makes sense. So we have our counter app at the top. We provide the counter block using the block provider to our counter page. And then within our counter page, we have a couple of components. We have the block builder, the floating action buttons, and our text below our block builder. So our floating action buttons, when we tap them, they'll add events to our block. And then our block will do some processing and then output some states, and then those states will be consumed by block builder and rebuild whatever widget you return. So in this case, our text is going to rebuild. A good question now is, what about if I want to do things like showing snack bars, navigating, dialogues? Do I put those in block builder or not? And the answer is no. We have another widget for that called BlockListener. And the API, or the definition is, it will handle doing stuff in response to state changes. So everything that's not building widgets, use BlockListener for. And it looks very similar to Block Builder. You still provide the type of block and the type of state that you're going to be responding to. But instead of a builder, we have a listener. And the listener is a void callback, so you don't have to return anything, but you can just put all of your logic in here. So if you want to show a snack bar in response to a state change, or if you want to show a dialogue, do it in listener and not in builder, because builder should be pure. It should only return widgets based on state. It can be called many times by Flutter outside of Block, because Flutter can choose when it wants to re-render parts of the UI. So you don't want to put things that you only want to happen once in a build method. Separate those and put them somewhere else, like BlockListener. And then similarly, we have a child widget, the child. And going back to the code, in our listener, now we can just basically access our scaffold, our closest scaffold, and call hide current snack bar. So if we have any snack bars that are currently being shown, get rid of them, and then show a new snack bar with some content. In this case, we'll just say counter : the value of our block state. And we'll end up with something that looks like this. So both the text in our counter is updating, as well as a snack bar popping up with the value of the counter. Pretty exciting stuff, I know. And you might think that we're done, but actually we have some refactoring to do, because we can simplify this even a bit further. So there's another widget which is fairly new called BlockConsumer, and it's pretty much taking Block Builder and BlockListener, sticking them together, and it's great for cases where you both want to do some sort of side effect as well as re-render parts of the UI in response to the same block state. So exact same thing, we provide the type of the block, the type of the state. It will infer or look up the block internally if you don't provide it. And then we have a listener and a builder where we can do side effects as well as rendering UI, respectively. So we can take the current snippet that we have, where we have a nested builder within a listener, and refactor it to look something like this, where we have still the same builder and listener, but our tree looks a little bit cleaner, it's a little bit easier to read, and you save yourself from writing a little bit of extra code, which is always good. And it's the exact same code as the previous slide, so you don't really have to change too much. So we've circled back to the UI, we've taken a look at the Flutter Block library really quickly, and now we can address the final point, which is how can we use this to be predictable and maintainable. So I'll split it into two parts. First, the predictable aspect. Predictable, we want it to basically be like really easy to figure out where things are happening, how bugs are introducing themselves if there are any, or things like logs and analytics. We wanted them to basically be kind of transparent, and we didn't want developers to be sprinkling those in our code base. We wanted everything to follow kind of like the same sequence and have a single place where we can kind of log all these changes or detect changes. And for that, there are a couple of overrides that we can add to our blocks. So the first one is OnEvent, and as the name suggests, it's just called whenever an event is added to the block. And we can override OnEvent in any block. And in this case, we can just call print, and print the word OnEvent followed by the actual event. And if we go back to the good old days where we had our just pure Dart example that we were using to test our block, and we run this again, we should see we have OnEvent triggered with the increment, OnEvent triggered with the decrement, and then we have our states emitted. And so you might be thinking, I expected actually first 0 to be emitted, and then the event, and then 1, and then the event, and then 0. And actually, this is happening because by default, all streams are async, so the events are added immediately, and then the block processes them after. So that's just how it works in Dart by default. But it's still pretty useful if you want to hook into like when are events actually being added to the block, and you can also do a diff between what events are added and what events are processed. Sometimes you might drop events or ignore events, so it's a useful hook for a lot of cases. Another one that's even more useful in my opinion is called OnTransition, and that basically gets triggered anytime a state change happens in the block. So right before the transition, or right before the state change happens, OnTransition is called, and the transition contains the current state of the block, the event that was emitted, and then the next state. So we can override OnTransition the same way as OnEvent, and just print. And if we go back to our example and run it again, we'll see the initial state is emitted, followed by OnTransition. We have the current state at 0. We add the increment event, and our next state is going to be 1. There's 1. And then another transition is about to happen from 1 back to 0 because of the decrement, and we have our 0. So that's all cool. We can track all the state changes from a single override, which is awesome. And some of you might be wondering, like, okay, what about if an error happens in our block? How do we hook into that? And there is an onError override for that, which gives you access to the error as well as a stack trace, if there is one. So we can demo that by just adding another print statement with the error in the stack trace. And we actually can't really do this yet because we don't have any exceptions being thrown in our block. So we have to go back to our counter block and let's add a default. So if we don't get an increment or a decrement, let's just throw an unsupported exception, just for the sake of this example. And then if we go back to our main, at the very end, after we add our first two events, we can add null. So that should force our block to go to the default and throw this exception, and we can see what happens. So now if we run all of that code, we'll see we get our states, initial, the incremented state, and then the result of the decrement. And then we get this huge stack trace with our on error and our exception unsupported event. And more importantly, it tells us exactly where this exception was thrown. So if you're logging all this information somewhere, you should easily be able to say, like, okay, the user first did this, that, the state changed to this, that, and the other, and then, oh, we got an error. It happened exactly on this line. Let's go reproduce this really easily. We don't have to waste time, and we don't have to wonder, like, did this error actually happen? Is it like a false positive, or oh, we'll ignore it until it gets reported again? You can easily reproduce all of those steps because of the detailed logs that you can get from the block. And you might also be thinking like, okay, we have to override this on every single block. That's really annoying if I have like 50 blocks in my application. I don't want to override OnEvent, OnTransition, and OnError every single time. That's a ton of code to be writing. So for that, we have Block Delegate, which comes from the block package. So it's pure Dart again, nothing with Flutter. And Block Delegate is useful if you want to basically have all those hooks, but in one place for every single block in your application. So if you have 50 blocks, you can override any of those methods that we just went through, and it'll apply for every single block in your application. So we can create an instance or extend Block Delegate and create our own custom delegate, and then we can optionally override any of those three overrides, or all of them if we want to. And the key difference here is we also get the block that was responsible for whatever happened. So we get the block plus the error and the stack trace, or we get the block plus the transition and the stack trace, or plus the transition, and we get the block plus the error. So you have the actual block that was associated with whatever happened, and you can easily basically figure out where in our application this happened and how did the user get there. So one place for all of this. And all we need to do once we've created our block delegate is just initialize it in our main. And now we can rerun the exact same code and remove all those overrides from our block. And we should see, we get all of our events. Now we see the associated block that those events belong to. We see all the transitions with the associated block. And then we see the same error with the associated block, but we don't have to log this all throughout our application. So predictability, we can check that off. Our application behaves the same regardless of who wrote it or how it was written. It's always following the same principles, and we can intercept the state changes at the same place. So regarding maintainability, my teammate Jorge and I actually wrote some tools. So there's an extension for VS Code as well as IntelliJ, and they help with things like generating block code. So you can literally right-click and say, I want a new block, name it counter block or whatever, foo, and it will generate all the code that you need. So the blocks, the events, the states, give you a to-do for I need to implement my business logic, and you don't have to worry about like, oh, I can obviously tell like Alex wrote this part of the code base and John wrote that part of the code base. Our goal was to have the code be totally basically identical regardless of where you look. There's no like telltale signs of who wrote it or how it was written, and you don't have to have developers basically be siloed in like individual parts of the code base. Everyone should feel comfortable jumping back and forth and do everything the exact same way. So the tooling really helps with that. There's also documentation. So pretty much everything I've just talked about and even more is at blocklibrary.dev if you're interested. There's a ton of sample applications and documentation, and I've even like been really fortunate to have members of the community reach out and offer to both update the documentation as well as translate it, which is crazy. It must be like super hard and boring to translate all that documentation, but there are so many people who are really willing to do that and spend their free time, which I really appreciate. And it makes it way more accessible to people who maybe don't speak English. So if you're interested in helping maintain the documentation in any way, I would love that. That's awesome. We also have tons of example apps, so not just counters and async counters. We have real life applications like how do I do authentication with Firebase? How do I do a GitHub search application with autocomplete? How do I do an infinite scrolling list? How do I do timers, to-do apps, weather apps? All these apps that actually hook up to real APIs and get real data. You can see all of that with step-by-step instructions on how to build the app, why it was built the way it was, and then you can actually download the code from the repo. There's a subdirectory called examples, and you can run all of this locally. And speaking of examples, I was actually just learning about this the other day, that actually Flutter Europe uses Flutter Block, which is awesome. I was really shocked and honored that they actually used it, and props to Dominik and the team for writing an awesome app. I'm sure everyone's using it, and it's a really cool app that they delivered for free on time for the conference. So just quick round of applause for everyone who ran Flutter Europe. And so we have accomplished our goals, but we have time for a bonus, which is this package called Hydrated Block. And it's not considered part of like the core set of block packages because it's kind of like a niche thing that we made, but it could be cool. So our problem statement in this case could be like, okay, I've made my app, I increment my counter a couple times, but when I kill my app and come back, the application state is lost, right? I start back at 0. So how can I easily implement some sort of caching in order to retain my application state? And that's where we can add the package Hydrated Block. So we can throw that into our dependencies. Now instead of extending block, we'll just extend Hydrated Block. Exact same input and output counter events to integers. And instead of just returning 0 for our initial state, we can return the hydrated initial state if it exists, and if it's null, then default to our old initial state, 0 in this case. And then lastly, there are some overrides, so a to.json and a from JSON. So we need to have a way to take our state and convert it to a map, and vice versa. So in this case, we'll take our state, which is an integer, and return a map count with the key count and the value of the counter. And then conversely, from JSON, we'll take that map, and then we'll return the integer from that map. And then in our main, all we need to do is, since we're using Hydrated Block, it has a dependency on path provider. And if you're going to use any plugins before you call run app, you need to make sure that your widget's flutter binding.ensure initialized is called. So add that in. Instead of using our old block delegate, we can use the Hydrated Block delegate, and then we can call run app again. And now we'll have on the left our old app. So when we run it and kill it, it should start back over at 0. And on the right, we have our hydrated counter, which continues from where it left off. And it's a really cool way to demonstrate how having a single data flow with immutable state and forcing everything to go through the same pipe has many advantages, including things like you can cache, you can put analytics in. If you watched Jorge's talk, he talks about a logger called Lumberdash, which we made, which basically has a bunch of plugins. So you can choose, maybe in dev, I want to write my logs to console, and in production, I want to write them to Firebase Analytics. So you can use that logger client, inject it into your block delegate, and then without writing any extra code, you can have all of your logs for every state change in your application done for you. So for us, that was something that was really powerful and really useful. We didn't want developers to have to sprinkle extra code or write lots of complex code to do things that we can make transparent and simple and handle them behind the scenes and reduce both the room for error as well as improve the efficiency of development, because people don't really, I don't think anyone here would be interested in developing caching layers and stuff like that. You'd probably be more interested in building real features that users are using, right? Or building cool animations or using Rive to integrate into your code base. So taking all that boring stuff out of the equation and just letting you focus on things that actually offer value to your customers was something that we really wanted to do. And with that, I will close. I'll say thanks for coming, everyone. If you want to learn more, again, blocklibrary.dev has all the documentation. And there's also a Discord server, so if you're interested in just chatting with people who use the library or have questions about it, I encourage you to join. And you can also follow me on Twitter. Again, if you're in Chicago, feel free to stop by and say hi to myself or Jorge, or visit our office for Very Good Ventures. And yeah, thank you so much. If you have any questions. Hi.
Hello, Thank you for your presentation. It was great. So I don't really have a question. I just want to thank you for your great job, especially for supporting part. I've seen answers on GitHub, which takes like 4 monitors long, and I don't even imagine how much effort does it take to support such great library and all those examples, like there are tons of them, and we really appreciate it. Thank you.
Thank you so much. Don't just thank me. I'm not the only one. There's so many people. Thank you.
Hi. I have a question. Why Block Library using RxDart?
RxDart?
Is it necessary? Example, I don't want to use RxDart in my application, and it's provide additional dependency. Is it really needed?
That's a good question. So when we first made it, we were using RxDart because we went straight from using RxDart with the block pattern, and it was a natural progression to basically see like, okay, this is what our code looks like currently. When we're making our own blocks, let's just abstract that. And we used RxDart for having things like behavior subjects, and also we could easily convert things to observables and do things like debouncing events, or using switch map so that we can cancel pending events and just process only the latest event. So it offered a lot more like power if people wanted to tap into it, but it was also hidden beneath the surface. I think that it's definitely a good topic to discuss. I mean, I think having RxDart as like a dependency that you can tap into is really useful for a lot of things, as Brian talked about earlier. But definitely you have to pick the right tool for your job. So if you don't need Rx and its capabilities, it's hidden beneath the surface. And if you need it, you can tap into it with a bunch of different methods that are more advanced and I haven't talked about here, but they're outlined in the documentation. It might be interesting to think about maybe like having a separate add-on that adds RxDart if you don't want to have it just shipped with the package by default, but that's kind of the history and why it was included to begin with. But yeah, there's definitely a lot of benefits to it, and it's not a very heavy library, and it seems pretty stable, so it seemed like a safe thing to include, but definitely limiting dependencies is a big thing that we need to keep in mind. So yeah, if you have any more feedback, I'd definitely recommend opening an issue and we can discuss it more, because I'm totally open to it.
Okay, thank you.
Thank you.
Hi. I have a question.
Hey.
I implement the application with authorization on demand, and in potentially each block can throw me return unauthorized error. How to handle it in your library? Because as I understood, I should pass the state as generic to the block implementation. Yep, and this unauthorized state somehow should be present in all hierarchy of states or something like this?
That's a good question. So for authentication, what we've typically done is we have a block that just maintains the state of the authentication of the application, so whether or not you're authenticated or not. And you can make that a global block by providing it above Material App so that you can access the authentication state anywhere. And typically, you might do something like provide the authentication block above Material App and then have maybe some sort of root widget, which based on the authentication state either renders an authenticated view or an unauthenticated view, so you can use Block Builder for that. There are other approaches as well, like you can even do the authentication directly in your main and use the native platform splash screen while you're figuring out if a user is logged in or not, and then just jump right into the screen, so you don't necessarily need to do that. But having an authentication block at the top level is definitely doable, and you should do that just by providing it above your widgets app, so Material App or Cupertino app, and then you can access it via block provider from anywhere in your widget tree. Hopefully that answers your question. Yeah.
Hi, thank you for your presentation. I have a question about canceling map event to state process, because, for example, I have a screen that have a search bar and user touches one letter and it should be reactive, so I send it to the block. The search starts, but the user in the meantime presses another button, and I want to cancel that that process. How can I do that?
Yeah. So I didn't cover that in the presentation, but there's actually a method called transform events that you can override in your block. So transform events sits right in between when an event is added to the block and when map event to state is called. And by default, it uses async expand. So for those of you who don't know, async expand basically means the order in which I add the events is the exact same order in which they're processed. So if you add 50 events because the user is typing characters like in an autocomplete or a search form, and each event makes a network call that's really inefficient because you're waiting for each network call to finish. So you can override that and actually use switch map or whatever you'd like really, and switch map in particular will only process the latest one, so it will cancel any existing events that are being processed and just process the latest one, which I think is what you're referring to. And there's actually an issue that was basically opened, and a lot of people asked that and gave a thumbs up to it, so I can share the link with you and you can take a look at the code example if you want.
Okay, thank you.
We have 1 minute. Yeah.
Hi Felix, I'm very grateful for your great library, and I have a question. Let's say we have block A and block B, and block B needs some information from the state from block A. How should we handle it? Should we somehow inject block A inside block B, or just store information from block A in some repository? How should we do it?
That's a great question, and I don't know if there's a right answer for that. Typically, I've learned that when you have dependencies between blocks, it introduces complexity into your application because now you have lots of streams that are dependent on each other. So if possible to avoid that, I think your application will be simpler. But there are, I think, valid use cases for when you'd want to do that. And in that case, the easiest thing to do, there we go, would be to just inject block A into block B. You can subscribe, and then anytime data is emitted from block A, just add an event in which you process asynchronously the data from block A inside of block B. There's an example in the architecture section of the blocklibrary.dev which outlines this, but that's something that we're currently trying to figure out if there's a better way to do that. So if you have ideas, definitely let us know. Yep. Cool. Thank you so much.